Hello, I'm Mr. McBrien. This is TEJ20 Multimeters. Yesterday we discussed schematics and how we can use these to communicate the contents of a circuit either to others or read a schematic in order to build a circuit according to someone else's specifications. Today we're going to talk about the need for measuring given components and given electrical characteristics, talk about the techniques for successful use of the tool we use, the multimeter, and we'll do a bit of hands-on work. Obviously that won't be part of the video. So we've learned though how to do all these calculations. We can calculate the current in a circuit, right? If we know the resistance and the voltage. We can calculate power and all these kinds of things. So why measure? Well, the answer is that calculations work great when we're considering a circuit that is working correctly the way it's intended. But there are questions that can't be answered that way. For example, is a connection soldered properly or is there a break? Is a battery dead? Is a power supply working? How many ohms is this resistor, and has it been damaged by, for example, excessive heat? Is this LED burnt out? So the multimeter is our primary device for answering these kinds of questions. As you might expect, a multimeter has various modes, various tools built into it. The most important for our purposes are the ohm meter, the ammeter, the voltmeter, and the diode tester. Each of these tools tests a different aspect of the circuit, and each of these tools has to be used in a slightly different way. So let's start with the ammeter. So remember, A stands for amps. So in order to use the ammeter, the first thing we do is we turn the dial to A for amps, or if we're expecting very low current, to one of the ones with a small prefix. So the ammeter will measure the current as that current moves through the circuit and through the meter. So what this means is we have to break the circuit to make a measurement. So if we want to measure the current through resistor 1, we first have to break the circuit and then insert the ammeter. So that current that goes through R1 also has to go through the ammeter. The ammeter is designed to allow current to flow through without resisting it. Therefore, that current is what we would expect without the ammeter as well. So it might look something like this. To make our measurement, we would turn our dial to amps. We would break the circuit between our battery and our resistor, and we would press our leads from the ammeter firmly into the circuit, and the current will flow accordingly. Current will flow from the battery through the red lead, through the ammeter to be counted, out of the black lead to the resistor, through the resistor, and back to the negative terminal of the battery. Now, ammeters are a little bit tricky to use. As I mentioned, to measure amps, current will flow through the ammeter. And multimeters, like any system, can only handle so much current. And you will see, as we saw in our little cartoon multimeter, that the settings have a range that they can accept. Never exceed that. And how do you avoid exceeding that? Start with the highest one. So if it says up to 10 amps, start with the 10 amp range. If you see 0, dial it down to one of the lower ranges, and just keep doing that until you see a non-zero result. If you go the opposite direction and the current's higher than you anticipate, you can blow a fuse in the multimeter or destroy the multimeter. Now, for this reason, we won't typically measure current experimentally in the classroom. If you want to measure current, call an instructor over and they'll help you make sure you don't wreck the multimeter. Okay, some of the ones that are a little safer to measure. So the ohm meter, if we want to measure ohms, remember ohms measure resistance. We need to look for the secret symbol of the resistance there. Turn to that and we can measure the resistance of a component. Now, we can also use that setting to confirm that we have a connection between two components. How would you do that? Well, you make sure the resistance between them is zero or close to zero. So, to measure resistance, we turn to the secret symbol of the resistance, that little horseshoe thing, and we disconnect the power from the circuit. It's very important that you disconnect the power. Otherwise, it will interfere with your measurement at best, if not wrecking your multimeter. Place the leads on either side of the component, and the ohm meter will force a little bit of current through the component and measure the resistance. So what should the resistance across a soldering joint be? Well, you probably realize by now that that resistance should be zero. So you can measure that resistance that way to make sure you got a good soldering joint. So here's an example circuit drawn to measure resistance through R1. We turn the switch off so there's no power to the circuit, and then find some bare metal on either side of the resistor and we can measure its resistance. Or we can pull the device out of our circuit and measure it directly on a non-conductive surface. To get an accurate reading, press firmly on the metal ends. So in this case, our measurement is 0.97. 0.97 what? Well, in order to figure that out, we have to go to the dial, and if we look closely, you can see K ohms. So that is 0.97 kilo ohms, or 970 ohms. All right, the voltmeter measures volts or potential. We can measure the potential difference between any 2 points. Notice that there are two V's here. You don't want the wavy line, that's for AC. You want the straight line for DC. So with this, you can confirm that you've got a good connection, that you're getting power to a given component. You can confirm that your batteries are live. Notice though, potential difference. There's no potential difference if there's no power supply connected to the circuit. So you need to make sure that the power supply is connected to your circuit. So in this case, we can see what we've done is, sure, the switch is turned off. That's fine because we're only measuring on the sides of the battery. Okay, the diode tester. Most of our multimeters have a diode tester function as well. This can be useful for various projects. You turn the dial to the symbol for the diode and apply the leads to the appropriate sides. So you can test diodes. It'll beep if you've got it set up properly and the diode's working correctly, or it should be able to light up a red LED to test your LEDs. Now, it's worth reminding again about the readings. The multimeter, depending on the type, will change units as you work. But you need to watch for prefixes either on the display or on the dial itself. Remember, if you put a capital M in front of ohms, it's a very different result than without that capital M. So 100 mega ohms is not the same as 100 ohms. In fact, it's off by a factor of 1 million. Now, you also need to be aware that there will be times when numbers are too big for the range the multimeter can handle. And it will communicate this as well, out of range. So for example, if your maximum measurement is 20 mega ohms and the resistance is higher than that, it'll need to tell you that it's higher than that value. Effectively, it's telling you in infinity. So you need to be able to tell the difference between 0, i.e. a good soldering joint, and the resistance of air, which is much greater than 20 mega ohms. So let's consider this for a second. It's different though for each multimeter, so you have to pay attention to your own multimeter. So if you want to see what a 0 reading is, set your multimeter up for resistance and connect the leads directly together. So push the two leads directly together so the resistance between them is 0. And in my multimeter I use for this picture, the reading of 0 looks like this. So you can see the units are shown above the screen in ohms, and it's 0.0 ohms. Now if you want to see infinite ohms, you can simply hold the leads apart when it's set for resistance. So if you hold the leads far apart, on my multimeter I see this, 0.L mega ohms. So it says more mega ohms than it can read. Okay, and remember to watch for those prefixes. They're extremely important. So that capital M is very important if you're looking at a value of, for example, 10 mega ohms. That's very different than 10 ohms. Okay, we can also use multimeter functions inside Tinkercad. So it has its own multimeters, and these are useful for practicing. We lose a few tricks, like we don't know about pressing very hard onto the leads and things like this, but that's okay. It will still show interference if you try to measure resistance with power on it and stuff like this. So if you're using Tinkercad, it'll work very much like the real thing. It uses theory to calculate what the current should be. Notice that you don't need to worry about blowing out an ammeter, but you do have to wire it in series, just like you do in real life. If you want to measure resistance, you can do that. You just need to make sure that you disconnect power to the circuit. And if you want to measure potential, you need to have a battery connected to it. So when you measure potential, then you're going to connect the leads for the multimeter and make sure you click the voltage mode. And you won't see any measurement at first. You've got to remember to click Start Simulation before you'll see a measurement of it. So if you want to measure resistance of a given component, you've got to remember to disconnect power. I've done it here. Connect the leads on either side of the resistor, change to resistance mode, and once again click Start Simulation. Measuring current, a great place to do it because you have no risk of burning out a multimeter when it's a virtual multimeter. Remember, you're going to connect power because there's no current without a potential. Break your circuit. So in this case, I broke my circuit here. It was running from the LED back to the ground, and now it's running through my multimeter. And be sure to click on amperage mode or ohm meter. And once again, if you don't click Start Simulation, you won't get a measurement. Okay, I think that's enough for today. So to summarize, multimeters are very useful devices as you build circuits. Ammeters measure current, have to be wired in series. Voltmeters measure potential. Your circuit has to be under power. Ohm meters measure resistance. You need to disconnect power in order to measure resistance. Each of those measurements has special characteristics. You need to be able to talk about how you can go ahead and use those tools accurately. So for your homework, please go ahead and complete the multimeter worksheet. You can look at the movie on how to use a multimeter, and either in the classroom or online, consider this circuit with 3 resistors in series. Measure the current before and after the first resistor. What do you expect? What do you see? I think you'll find the result useful. Thanks very much. Have a great night.